So let's talk about amide hydrolysis. So converting an amide into a carboxylic acid and an amine. So the conditions will be acid, H plus, in water, hydrolysis meaning water. And this is the tough one, right? When we think about reactivity and like things like monocarbonyl, amides are really, really stable, right? Why are they stable? They're stable because this nitrogen can do lots of resonance, right? So that makes this bond very more like more have pi bond, some pi bond character. It makes this less reactive because we're doing resonance. So we're gonna need some acid, and we're gonna need probably some heat. Probably have to heat this up too. And also notice at the end, you don't end up with a carboxylic acid and amine. You end up with a carboxylate anion, and a protonated amine, right? Because again, when you're making a carboxylic acids are they're acids, and amines are bases. So let's go through this whole thing. So the first step in all these acid condition steps is going to be a protonation. Great. And you could do a couple different things if you want to here. I can show a variant of this, but let's just go with the classic protonation here. All right, so we've made that more reactive. So protonation. Next step is going to be addition. Water's our solvent. So there's a lot of that around. Do that addition step. We've seen classic over and over again. Now we get to a tetrahedral intermediate. We're going to need to do a proton transfer to make the amine the better leaving group. Nitrogen rather have a plus charge anyways, so that's okay. So we do that proton transfer, redraw our tetrahedral intermediate with the protonated nitrogen now. Plus charge there, balancing our charge. Do our classic deprotonation elimination step. So deprotonation, lose that hydrogen right there. Remake that pi bond, elimination. Great. And most of these were actually done at this point, but this is a little different case because we generated an amine. Because we generated amines, of course, are reactive. The lone pair is pretty reactive. It's basic. And of course, we also made a carboxylic acid, and acids are going to be acids. So what's going to happen here is actually this is going to be deprotonated. So we actually have an added step here. One more deprotonation. It's really kind of acid catalyzed still because this is really going to act like an acid to restart this. So it is in a sense acid catalyzed. So that restarts this. This is amide hydrolysis. One interesting thing to think about: what would happen if this was an alcohol? If this is an alcohol, we get something completely different. We'd actually get an ester in the amine, and this would be acid catalyzed. So it's something to think about. We could do amide esterification instead of hydrolysis with water. Esterification would mean we'd have an alcohol here as a solvent. So something to think about as we go forward.